Hello friends, welcome to Learners Forum. So in conversion, let us see the next topic which is octal to binary and binary to octal conversion. So we will see both these conversions in this topic now. So before solving the problems, we need to know the representation of 0 to 7, that is the basic numbers in octal representation. So octal, which means the base is 8 value, and in terms of 2 power, it can be raised to 2 power 3, which means each decimal value will be represented by 3 number of digits. So that is the basic procedure. So based on that, let us write the representation for various numbers in 3 digits. So for example, 0 is represented with 3 digits as triple zeros, and 1 is represented as 001 in binary, and 2 is represented as 010, 3011. For 4 it is 100, for 5 it is 101, for 6 it is 110, and for 7 it is 111. So this is the representation. So based on this representation, let us solve an example. So given is an octal number 37.45. So we have to convert this octal number into its equivalent binary value with the base 2. So to convert this, we have to know this particular value. So we will just replace this set of values in the given number. So 37.45, which means it has both the integer part and fraction part. So for 3, the equivalent representation in octal is, from the table, it is 0, 1, 1. So we can write it over here. Next for 7, the equivalent representation is 1, 1, 1. So it is written over here. Next for the fraction part, which is 4, 1, 0, 0. Next for 5, it is 1, 0, 1. So from the table, we have simply picked up the values and written over here. Now we have to write it together to get the equivalent binary value. So for 37, the values whatever we have written 011, and for 7 111 is written, followed by decimal number, then again 100 101. So everything is written together to get the equivalent binary value for the given octal number. So this is the way we have to convert an octal number into its equivalent binary. Let us solve one more example. Given is 672.13. We have to convert this octal number into its binary. So for 6, let us write the value from the table, which is 110. Next for 7, it is 111. Next for 2, it is 010. Then after the decimal point we have 1 3. So for 1 it is 001, and for 3 it is 011. So these are the respective values. Now we can write the equivalent now we can write the equivalent binary value, which is 110 111 010 decimal 001 and 011. So this is the equivalent binary value for the given octal number. So this is the procedure for the conversion. Now let us see the binary to octal conversion. So given is a binary number, and we have to convert this binary number into its equivalent octal number, which is to the base 8. So for converting a binary to octal number, we have to follow a small rule. That is, for integer part, we have to move from right to left in 3 bits, and for fraction part we have to move from left to right for 3 corresponding bits. So these are the rules to be followed. Now based on the rules, let us solve the given example over here. So first is the integer part, where we have to move from right to left. So the integer part and fraction part has to be segregated into 3 bits of each. So starting from the right side, just move towards the left for 3 bits. So we will have 3 ones. So that is taken separately. And again, for the next terms, again move from the right to left position, which is 1 and 1. So we can keep it as such, but we need 3 bits. So since we have only 2 bits over here, add an additional 0 in front, but make sure not to add the 0 at the right side because it will make a difference. Next decimal 110, we have only 3 bits, so we can keep it as such by moving from left to right. Now we will write the equivalent consolidated value for the binary. So 011 is represented with 3. From the table we can pick up the value. For 011 it is 3. So we can write it over here. Next for 111 the equivalent value is 7. So 7 is written. Next 110, so the equivalent value is 6. So we can write it over here. So for the given binary value, the equivalent octal value will be 37.6. So this is how we have to convert the binary number to an octal number. Now let us solve one more example. Again, we have both the integer part and fractional part. Segregate into 3 bits of each. So for integer part, we have to move from right to left. So moving from right to left, it is 0, 1, 1. First set of 3 bits is over. Next, we have 0, 1 and the third bit is not available. So we can take an additional 0 to make it as a 3 bit. Dot. We have only 2 bits moving from left to right. So 1, 1 and we have the third bit as 0. So always for the fractional part we have to add 0 to the right side, and for integer part we have to add 0 to the left side. Only then it will be a proper value. Now we will write the equivalent value for these set of 3 bits. So for 0, 1, 0, the equivalent value from the table is 2. So we can write it as 2. For 110 it is 6. Again 110, so it is 6. So the equivalent value for the given binary number is going to be 26.6 to the base 8. So this is the equivalent octal number. So this is the procedure to convert any octal to binary number or a binary to octal number, provided we just need to know the equivalent representation values in octal. So this table has to be known and the rules has to be known for this conversion. You can remember the other short code also, 8421. So 8421, this rule can be applied to get the equivalent representation in case if you forget the table. So 8421 in the sense, we can just fill the value of zeros and ones accordingly to get the number. Since it is 2 power 3, we can just take only the 4 to 1's value. For example, if we have to represent the value as 5, it is nothing but 4 plus 1. So where we have 4 and 1, there alone we can take the binary value as 1 and the remaining can be taken as 0. So adding the value of 1's, we have to get the equivalent decimal value, which is 5. So this is how we can take the representation in terms of 8421. Similarly for 3, if you take, it is 2 plus 1. So the position of 2 and 1 will get the value of binary and the remaining is 0. So this is the way to fill the table. In case if you forget the table, you can make use of this 8421 rule